Welcome my dear students. This video is the second part of the previous lecture, which is Newton's law of motion, and we are going to discuss about second law and the third law as well in this video. So let's start without wasting any more time about the second law. In previous video we have learnt about first law, that where a body is given external force to stop its motion or make it in motion while it is resting on a surface. That means if you apply force to any rest body, it will start to move, and if you apply force to a body which is in motion, it will stop. If it is not done, if that external force is not applied, the static body will be in rest and the moving body will continue to move in same direction with same velocity. But what is happening in the second law? Second law tells us about the change of momentum. We have discussed about the linear momentum, which was P equals to m into v, that is momentum is the product of mass and velocity of any object. But second law is dealing with the change in momentum, change in P rather, with time. That means the rate of change of momentum. It says that whenever the force is applied externally to a body, its momentum change or its rate of change of momentum will be proportional to the amount of the force applied externally. Okay, if you apply any force, it will be proportional to the rate of change of momentum, that is delta p with delta time. Okay, this is the rate of change of momentum. Delta p is change in momentum, delta t is change in time, and this momentum change will be in the direction of the applied force. Okay, applied force जिस डायरेक्शन में किसी बॉडी पे एक्ट कर रहा है, उसका रेट ऑफ चेंज ऑफ मोमेंटम उसी डायरेक्शन में होगा, और वो फोर्स का वैल्यू विल बी प्रोपोर्शनल टू द रेट ऑफ चेंज ऑफ मोमेंटम. We have learned that momentum has an expression m times with v. Let's say a body having initial velocity as u and its momentum will be mu. Okay, fine. And final velocity as v and its final momentum will be mv. So how can we find the change in momentum? Simply by subtracting mu from mv. Mu minus mv gives us the expression of change in momentum. If you divide it by time, it will give us the rate of change of momentum. Okay, so second law is telling that, second law of Newton's motion telling that this is equals to the value of force applied. This is equal to the value of force applied. So from here we can take m as common, v minus u by t. And there is an interesting part in this expression. See, we know that when a body is having a velocity and its velocity is changing with respect to time, it gives us the expression of acceleration. Okay, it gives us the expression of acceleration if the velocity is changing with respect to time. Okay, here initial velocity u and final velocity is v. This is the change in velocity and it is happening with respect to time. That means acceleration can be written as v minus u by t. So we can replace this entire expression by a, that is acceleration. So m product of acceleration, which is equal to the force applied externally to the body. So this is the numeric expression of second law of Newton. This is the numeric expression of second law of Newton, where force applied becomes equal to the product of mass of that body on which the force is applied and the acceleration of the body. We know that third law is very much simple. Third law is very much simple. See, give attention. Whenever you apply any force to object, that object is giving you a reaction force. Okay, आप इस वॉल पे आप अगर फोर्स करेंगे, if you apply force to this wall will give you an opposite and equal force. if you place this body on a table, this body is giving downward mg and this table will give it upward and equal reaction force. This is normal reaction force. Okay, this is actually the statement of third law. So third law, what it is saying, that every action force is having equal and opposite reaction. Okay, equal and opposite reaction. So this force will be equal and opposite to the normal force. Okay, so from here a concept of linear momentum conservation comes. Linear momentum conservation, we know that linear momentum is P equals to mv, which is linear momentum. Now how it is conserved? From the expression of second law, we know that F equals to ma, and this acceleration is nothing but v minus u by t. So if you don't apply any force, let's say this force's value is 0, say F equals to 0 means you are not applying any force to any system. So what will be the expression? M dot v minus u will be 0, and now v minus u will be 0, so v will be equals to u, that is final velocity is equal to initial velocity. And you simply, if multiply this 2 with m, multiply by m, we will get mv equals to mu. That means final momentum equals to initial momentum. So from here we can conclude that any particle, if the external force applied on this particular particle is 0, or any force is not applied, the initial momentum will be equals to the final momentum, and from here we can write mv minus mu will be 0. That means linear momentum is conserved. This is the principle of conservation of linear momentum. Okay, so that is all in this video. We have discussed about second and third law, and few more examples and complicated problems are given in the previous video, which is titled as pulley problems, how to solve the pulley problems, and the link is given in the description box. You can check it out also. So if you like this video, don't forget to share this to your friends so that they could have the clear idea of the entire chapter, which is Newton's law and motion. And subscribe my channel. Don't forget to hit the bell icon so that every notification you get as soon as I post any video on my channel. So stay safe, stay with physics. Goodbye.